So the last topic in this particular section deals with the order of results that are associated with operations that affect the results order. So we've talked about collections and how ordered versus unordered collections can impact or affect the results order. Now we're going to talk about operations in the stream that can affect the results order. So we'll start with intermediate operations first. Certain intermediate operations affect the ordering behavior of a parallel stream. For example, things like sorted, unordered, skip, and limit all have an impact on how things are ordered or not ordered. And they also have an impact in terms of how well things perform. So here we have the encounter order being, this should be 3, 1, 4, 2, since the list is ordered, not sorted, but ordered. So this is going to start out being ordered. But then we're going to start applying some operations here. And this is where things get really tricky. So keep in mind, this is a parallel stream, but we're going to apply certain operations that are called stateful operations. And one of the classic stateful operations is distinct. Now, I should probably have given slightly different values to make this more interesting. I probably should have had, 3 repeated or something. But what distinct does is distinct is an intermediate operation in the stream that says, get rid of anything that's duplicate values. So if it turned out that we had the value 3 appear multiple times in the list, distinct would filter it out and only have one, didn't matter which one, it would only have one of those elements. Now, why is that stateful? Because distinct requires looking at the entire stream before it decides what's distinct or not, right? You can't sort of look at a stream one element at a time and say, oh, that one's clearly distinct, because you haven't looked at the ones after it yet. So distinct actually has to batch up or queue up all the elements in the stream before it can decide what's distinct. Likewise, limit is also a stateful operation, because you have to keep track of how many things you've seen in the input so far. And that gets particularly tricky with stuff that requires encounter order to be preserved. So limit is also a stateful operation. And the consequence of this is that the final result here, because list is ordered, will be the values 8 and 4, assuming that I didn't make any changes to the input here. However, this will actually run relatively slowly. This code will run slowly due to the stateful semantics of limit and distinct and how that interacts with parallel streams. So remember I mentioned before how the semantics will be the same. We keep the semantics preserved, but the performance will suffer because it has to do things like queue things up to keep track of distinct, and it has to keep track of the limit, and that has to be looked at in the context of encounter order and so on and so forth. So this code will actually not run very fast, even though you get the right result. Now here's one way to solve this problem. One thing you can do is you can actually use yet another intermediate operation called unordered. And unordered says, I don't care if the original list was an ordered collection, and it therefore should have ordering preserved. You just told me you don't care about the order. And so if you use unordered, it's going to be able to speed things up quite a bit because it won't have to try to order everything in the results. So that may help performance in a parallel stream environment. You may get some strange results, stranger results, but it should still be correct. Just as certain intermediate operations affect the ordering behavior, certain terminal operations also affect the ordering behavior. And these are actually quite easy to keep track of because it has the word ordered on them. So one method called for each ordered is a terminal operation. And the terminal operation is going to ensure that the output is ordered. So in this particular case, what we're going to do is we're going to make a list. We're going to have a concurrent linked queue. We're going to have a parallel stream. And what this is going to do is it's going to use the for each ordered method, and it's going to add the elements into the concurrent linked queue. And that addition will take place in encounter order. So even though these things will be called in multiple threads of control, they will be called in the right order. And we use a concurrent linked queue here just to make sure that we don't have race conditions and so on. So this approach will end up with the results in this list, ultimately, in encounter order, although it may be a bit slow because it has to rearrange things and reorder things. Conversely, here's how we could do things if we use the for each method. and the for each method doesn't obey encounter order. So the order and the results may not match the encounter order, but it'll also probably run a little faster because it's not trying to rearrange the output to match encounter order. Okay, so those are just a few more discussions about the way in which the aggregate operations you use in a stream can affect the ordering behavior.